Hi everyone, welcome to my channel. In today's video, we will discuss the topic for week 9 for this subject PPD or power plant diesel. So this is PPD week 9 video discussion. So we will discuss the topic scavenging and supercharging. We will evaluate the need for scavenging diesel engines and assess pressure charging methods for diesel engines. We will also discuss the starting and reversing, how the engine is prepared for starting, stopping, and reversing. We will also discuss the difference between scavenging and supercharging for diesel engines. And we will also explain starting and maneuvering requirements, sequence for direct coupled, reversible, and geared propulsion diesel engines for peaks and controllable pitch propeller applications. And we will also describe with the label diagrams to indicate major components, typical maneuvering and reversing systems for propulsion diesel engines. And the last part of this video, we are required to discuss, to demonstrate the procedure on how to prepare engine for starting and stopping using the actual institution engine simulator and monitor operation based on the given instruction. Make use of the engine laboratory room or engine room simulator ERS for conducting the laboratory exercise. So I will use actual engine room simulator at the last part of this video to demonstrate the procedure on how to prepare engine for starting and stopping as well as for reversing. So this requirements is maneuvering. So required for demonstration maneuvering. So let's get started. So what is scavenging? In an internal combustion engine, scavenging is a process of replacing the exhaust gas in a cylinder with the fresh air fuel mixture or fresh air in case of direct injection engines for the next cycle. So here we have a simple video illustrating the process of scavenging. So as you can see here, this area, this is intake or scavenging. Or let's say scavenging of main engine of the ship. So scavenging, it is the process of replacing exhaust gas in a cylinder with fresh air. So as you can see, the fresh air here is entering at the intake port. This area here is intake port. So this area of cylinder liner here, there is an intake port here. So this is the it is connected to this pipe is connected to intake manifold, wherein the fresh air is collected. So when the piston is moving downward, the intake port here is open. So therefore, the pressure of fresh air here is entering to the cylinder. So as the exhaust valve open here, there is exhaust valve here like this for two-stroke engine. As this exhaust valve open, when there is a fresh air entering here, it pushes the exhaust gas out here in the exhaust outlet, going to exhaust manifold. So that is scavenging, replacing. So remember the keyword, replacing the exhaust gas in the cylinder with fresh air. So as the fresh air is entering here, as you can see the blue color here, this is fresh air. The exhaust gas is being replaced with fresh air when the exhaust valve here is open. So the exhaust valve here is not shown, but it is understood there is exhaust valve in here, in this area. So that is scavenging. Next, we have here the scavenging methods. So in scavenging methods in two-stroke engines, we have here uniflow, loop flow, and cross flow. So in uniflow, so this is common, uniflow. So the fresh air from intake manifold is entering here at the intake port of the cylinder liner. These are all intake port. So the flow of this fresh air, this one will enter through intake port and will enter to the cylinder. During exhaust stroke, the flow of gas is, or exhaust gas is expelled or released through exhaust valve in this direction. So this is called uniflow, from intake port to exhaust valve to the atmosphere. That is uniflow. Now we have here the loop flow. Loop flow in the cylinder liner, this is cylinder liner, there is intake port and there is also exhaust port. So this is the direction. So the air is entering in the intake port and it is going up to the upper portion of the cylinder, and it will circulate like this direction as the arrow is showing here, and the exhaust is released here at the exhaust port. So this is loop flow. Now we have here also the cross flow. So cross flow we have also here. So as you can see here, the exhaust port in the loop flow and the intake port is aligned, but the exhaust port is located on top of this intake port. But here a little bit difference. In the cross flow, the intake port is entering at this side, at the left side, and the exhaust port is located here at the right side. So this is cross flow. So the direction of the air here inside is like this, to the right. You see, from left to the right. But here in the loop flow, from left, and it will go up to the upper part of the cylinder, and it will release here at the left side also of the exhaust port here. So these are all scavenging methods in two-stroke diesel engines. Now let us proceed here. So we have here the so-called supercharger of IC engines, or supercharger of internal combustion engines. A supercharger is an air compressor that increases the pressure or density of air supplied to an internal combustion engine. This gives its intake cycle of the engine more oxygen, letting it burn more fuel and do more work, thus increasing power. So we have here the simple video illustration of supercharger. So this supercharging system uses turbocharger. So this is turbocharger, as you can see. This is turbocharger. So how this system works? Turbocharger is working by means of engine exhaust gas. As you can see here, this is engine exhaust gas. It's flowing here to the exhaust outlet, to the exhaust manifold, and entering to the turbocharger turbine side, turbine wheel. So turbine inlet. So this exhaust gas of the engine causes or pushing the turbine wheel of the turbocharger so that the turbocharger will spin or rotating in very fast speed. See? And this exhaust gas will be also out to the exhaust outlet and going to the exhaust pipe, going to the atmosphere. So as you can see here, as the exhaust gas is flowing to the turbine wheel, the compressor wheel is also turning. Why? Because they are connected in the same shaft or in common shaft or in one shaft. They are connected. So they have the same speed, turbine wheel and compressor wheel. So as this compressor wheel is rotating or spinning in a high speed, so in my ship, the main engine, the main engine RPM is 160 revolution per minute, and the turbocharger speed is 16,000 revolution per minute. So it is rotating in a fast speed. So as this compressor wheel is rotating in a high speed, there is a suction of air from the atmosphere, from your engine room, in here in the air inlet. Here. So it is being compressed in the compressor wheel, and the compressed air is being delivered or released to the outlet. So this is not here is the oil, the lubrication, the oil outlet, and we have here the oil inlet. So this is the lubrication of the bearings. But here we are talking the air, so charged air flow to the charger intercooler or the air cooler. So the air is being compressed and it is delivered through air cooler or charger air cooler or charged air cooler. And after that, so here there are about 120 degrees Celsius air temperature here at the outlet of the turbocharger compressor side and inlet to intercooler or the air cooler. But the outlet here is around 40 degrees Celsius. So we don't need a lot of high temperature to the cylinder, air cylinder, to supply to cylinder, because in every 1 degree of increase of scavenging air temperature will also increase 10 degrees of exhaust temperature here. So we don't want that because our engine will be damaged. So we maintain at 40 the scavenging air temperature. So here it is supplied to the engine cylinder for more power, for more combustion. So it is explained here. So this is the working process of the turbocharger. So remember, supercharger increases the pressure or density of air supplied to internal combustion engine. That is supercharger. So let us proceed. We have also here pressure charging. Pressure charging utilizes the heat energy present in the exhaust gases to drive the compressor. It results in an increase in power is obtained in proportion to increase in the charged air density. So this example is the same with the previous example here. Here, this is the same. So I will explain. So as you can see here, this is also uses turbocharger. This is turbocharger. So there are types of supercharging. There are engines uses turbo blower, different types of blower. But here in my example, we use turbocharger. So pressure charging utilizes heat energy present in the exhaust gases to drive compressor. Its result in increase in power is obtained in proportion to the increase in the charged air density. So as you can see here, the exhaust gas is flowing. So from engine, when the exhaust valve is open, the exhaust gas is flowing to the inlet of the turbocharger turbine side. So as this exhaust gas is passing through the turbine wheel, here it will spin the turbine wheel in a high speed, and this exhaust gas also released to the exhaust pipe to the atmosphere through your exhaust pipe outlet, so to the atmosphere. So as this exhaust turbine wheel rotating in high speed, the compressor also rotating in high speed because they are connected in common shaft here, the same shaft. So as this rotating, there is a suction of air, as you can see here. So from your engine room, and this air is being compressed by the compressor wheel, and it is delivered through this pipe, and it passes through air cooler. This is air cooler. So from 120 degrees Celsius to 40 degrees Celsius, the outlet of the air cooler. So the temperature of air here is around 120 degrees Celsius, and the outlet of air cooler is around 40. So it is supplied to the engine for more combustion. You see. So this is pressure charging. Pressure charging. So we have another topic here. How the engine is prepared for starting, stopping, and reversing. So in this question, the explanation here should be for maneuvering. So this is maneuvering. So this is container ship, and this is tugboat assisting the maneuvering. So this is living in port, or berthing or unberthing. So berthing is living in port. No, unberthing is living in port, and berthing is maneuvering to alongside in port. So this is maneuvering. So maneuvering is an operation during which a vessel enters or exits coastal waters of a country, or this is channeling, for example. Crosses several ships or a lot of ships. There are a lot of traffic So crosses several ships on the way and proceeds towards or departs from berth or jetty of a port. A ship may need to maneuver not only while arriving or departing a port but also while crossing canals and traffic zones. So the purpose of maneuvering, for example, if the vessel enters and exits coastal waters, and also crosses several ships. So there are a lot of traffic, a lot of ships, and also departure. So departs from berth or jetty or port. So and also we need also to maneuver not only while arriving or departing a port but also while crossing a canals. So channel or canals like Panama Canal and traffic zone. So if there is a lot of traffic, need also to maneuver. So that is maneuvering. So example here is leaving on port or arriving on port, or departing on a port or arriving a port. So this is the example. So here, before maneuvering, we will check the status of your main engine control system. Main engine control system. So as you can see here, the turning gear is already disengaged. So for example, departure. So your turning gear is already disengaged. As you can see here, the indication is illuminated disengaged. This one. So here, the turning gear. And then, here also, so why this is, this one should be, a minute. So this one should be the control is transferred to engine control room. If we maneuver through engine control room. So this is the indication, as you can see, and this is your telegraph. This is your telegraph, this one, and this is your engine throttle. So here, as you can see here, you have no alarm. So this is ready. As you can see here, your puncture valve is already open. Your main engine auxiliary blower is in auto position and both switch on, you see. So we already check our main engine local control. Here also, we have here our maneuvering system. So who will prepare all of this? The engineers. So the second engineer. So here, our starting air valve block is already open. As you can see here, the open indication is illuminated. Our safety air block valve is open. So open, it is illuminated. Open indication. Our starting air distributor block is open. So this is illuminated. As you can see here, there is a connection here. You see this solenoid valve. This is solenoid valve. This is solenoid valve. This is solenoid valve for starting air distributor. valve block. Here also, it is already transferred from local. So this local is from engine side, local control console, and this is already transferred to remote, meaning to engine control room. So as you can see here, our puncture valve is already open indication. It is green indication. So here the required solenoid valve, you see, it's our solenoid valve, is indicated already green. So this means open. This means open. This solenoid valve is open. This solenoid valve is open. So our maneuvering system now is ready. So ready. Now here we have here also the main engine control system indication. So as you can see here, we have no alarm. So we have no alarm. So this means the system is all ready for maneuvering. So our governor is indicating already in remote. So meaning it is transferred already to engine control room. So we have no alarm. See, we have no alarm. So everything is ready. Everything is ready. So here we have also here the main engine control. So this is already located in the engine control room. So as you can see here, we have no alarm. So this is ready. And this is our engine telegraph. This one. This is our engine telegraph. This is indication. And this is our main engine throttle. This is our main engine throttle. This one. This one. This one is our main engine throttle. And this one is our engine telegraph. And as you can see here, this one is engine, the responsibility transfer is in engine control room or ACR. So we can maneuver here inside the engine control room. We can maneuver the ship. But in this system, this system is automated system. We can transfer also the responsibility to the bridge. So the bridge will also give command here in the engine status. For example, already at sea. So the bridge will press this button and the engine department in engine control room will acknowledge, press also. So so that your the program of your automation system, governing system will work properly. Will give more power to the engine, throttling the throttle system will be working properly as demand. So before maneuvering, the bridge will put standby here and engine control room will acknowledge, and when finish engine is indicated here, that means the bridge give the command of finish engine. So the engine control room also will acknowledge here finish engine. But now here, since we are maneuvering, we will maneuver the ship. We will transfer the responsibility to the bridge so that they can use the throttle like this in the bridge. So we'll transfer to the bridge. So now, still here. So we'll transfer to the bridge. So we click this one and the bridge will acknowledge. So when the bridge will not acknowledge, this is still blinking. But when the bridge acknowledge, this one will illuminate steady. So no more blinking. So now the bridge is ready to maneuver the ship. So as you can see here, the indication of the starting air is open. So the ship is ready to maneuver because the responsibility is already transferred to the bridge. So now they can start this throttle to maneuver the ship. So as you can see here, there is no indication of alarm, so everything is ready. And your telegraph, so there are telegraph that is separate, but here in the system, the telegraph is together with the throttle. So this is a sophisticated system. So I all experience this system, both the separate telegraph and the combination telegraph to the throttle. So now the bridge can maneuver the ship in this condition. So that is how to prepare. So the whole preparation is another scenario, but here also here is only the preparation for starting, stopping, and reversing. So we shortcut the demonstration because there are another scenario that the complete procedure to prepare the main engine for departure. So this is ready to maneuver on the bridge. So at the end of this video, I will show you the actual engine room simulator to demonstrate all those I had discussed. So here we will proceed to the what is the difference between scavenging and supercharging for diesel engine. So I already discussed this one, but I have to make it review because in the topic this is also included that we have to differentiate. So now scavenging. So as I said before, so scavenging is the process of flushing out borne gases from engine cylinder by introducing fresh air in the cylinder before exhaust stroke ends. So here, as I said earlier, so there is an inlet of this pressure of fresh air that is entering to the cylinder when the piston is moving downward and the intake port here is open. So this fresh air will push the exhaust gas. When the exhaust valve is open, the exhaust gas is released to the exhaust outlet here. So flushing out borne gases. So there is borne gases here. So the fresh air is pushing the exhaust gas to release here in the exhaust gas outlet. So that is scavenging. So in two-stroke engine, but in four-stroke engine also, this is the same, but in two-stroke engine, four-stroke engine, there is intake valve here. In the two-stroke engine, there is no intake valve, but there is a scavenging port here. There's only exhaust valve. But here in the four-stroke engine, there is an intake valve to open. Then the supply of air is entering here. So when the exhaust valve is closed, it is this release, but released by the upward push of the piston. So not by air scavenging. So air scavenging is applied to the two-stroke engine. So that is scavenging. Supercharging. Supercharging is the process of supplying higher mass of air by compressing the atmospheric air. So I already discussed this before. As you can see here, as the exhaust gas is flowing here to the turbocharger, the turbine wheel of the turbocharger will turn in a fast speed, and the compressor will also turn in a fast speed because they are connected in the same shaft. And there is a suction of air from the atmosphere from your engine room then this air is being compressed by the compressor wheel, and the compressed air is supplied through air cooler, and the temperature of air from 120 it is reduced to 40 at the outlet of the air cooler, and it is supplied to the engine cylinder. So that is supercharging. So we will proceed here. Direct coupled reversible propulsion diesel engines. So when you see direct coupled, as you can see here, this is our engine. And this is our propeller shaft, and this is our propeller. So your propeller shaft is directly coupled to the engine flywheel here. Directly coupled. So you cannot see any gearbox here or reduction gear. You cannot see, because this is direct coupled engine. So when starting or stopping this direct coupled engine, for example, you start the engine to move the vessel forward. So you start this throttle. So the engine will push the vessel ahead. So as this one is ahead, but if you start the engine to astern, the vessel will move backward. So every time you stop and start this engine, for example, you want to stop the vessel from moving forward, so you stop this engine. But when you want the vessel to move backward or to astern, so you have to stop this engine and then you have to start to astern. This is astern. So this is direct coupled engine. So directly your propeller shaft is directly, or the load is directly coupled to the flywheel. So now during maneuvering, the bridge will give command. So if this is separate, they can give command to engine either ahead or astern. So but if this is a combination, they can also give a command. So when it is the command from the bridge is ahead, so the engineer in the control room will start. The engineer who maneuver the ship, for example, the chief engineer or the second engineer or the third engineer or the fourth engineer. So there are chief engineer that they don't want the junior officer, the fourth engineer and third engineer, as well as the second engineer also. They don't want them to maneuver. But in my experience, so when I was a chief engineer, so all of the engineers, I let them to maneuver the ship. So when the engineer maneuver, they can the command from bridge is ahead, so they can start ahead. So this is the indication. And if the bridge commands is astern, so they can the engineer can start astern. So if the telegraph and the throttle and the telegraph is combined into one, so this throttle only will be operated. But if there is a separate telegraph, so the telegraph should be also operated before this throttle is operated. So now, since we transfer the control to the bridge, as you can see here, the bridge is illuminated, the indication here. So the bridge can maneuver the vessel. So they can use this throttle on the bridge, they can maneuver. So in my video, that's last part on this video, I will show you the actual simulator on how to start, stop, and reversing this system. So we have here the geared propulsion diesel engines. Geared propulsion diesel engines. So we have here the reduction gear. Reduction gear, and the reduction gear. That's why this is geared propulsion. So this is propulsion, this is propeller. So this reduction gear in a automobile is called transmission, but in the ship this is called reduction gear or reduction gearbox. So we have here the diesel engines, port and starboard, or left and right, and we have here the clutches. These are all clutches. So when the vessel is maneuvering, so since there is a clutch, so the one who operate will engage the clutch. So this propeller will turn. This one also. So this example, because there is a gas turbine engine. Remember that gas turbine engine is used for a fast speed vessel. For example, the naval ship, the warship, the destroyer ship, the warship. So they will be using this gas turbine. This is for fast speed. This is also fast speed, but more fast, the gas turbine. So using this gearbox, you can, so for example, the operator or the one who maneuver, the captain or the chief engineer, for example, in the engine control room, actually the captain will only give the command. The chief officer will maneuver on the bridge, or sometimes there is a pilot. Not sometimes, but most of the times there is pilot. The pilot will command, and the captain will maneuver, or the chief mate will maneuver. So it's depending on the arrangement. But when the engine room will maneuver, engine control room, so the chief engineer or the second engineer will maneuver. So during my time, I let the second engineer to maneuver. But if I want to maneuver, I want to maneuver also the engine. So for example, the one who maneuver the engine or operate the engine. So for example, I will not use diesel engine, so I will use, for example, this is Navy ship, so I will use gas turbine. So I will not engage these clutches, and I will engage this clutch. So I will use this engine, but I can use also, since this is multi-speed gearboxes, I can use also this diesel engines and this diesel engines and this one. So the vessel is running very fast but consuming a lot of fuel. So this is geared propulsion engines because there is a gearbox or gear reduction. So this is also example of geared propulsion diesel engines. So this is the gearbox, and this is your engine. So when the operator engages the clutch here, so at the remote location, so this propeller shaft is turning, and this propeller is turning. Then the ship is moving ahead or forward, or moving astern or backward. So this is geared propulsion diesel engine. So we will proceed to the fixed pitch propeller or fixed propeller. So the fixed pitch propeller type propellers are casted, and the position of the blades and hinge The position of the pitch is permanently fixed and cannot be changed during the operation. They are normally made from copper alloy. So as you can see here, this is installed in a fix. So you cannot see any other installation here. This is fixed or permanently fixed or permanent. So when this is turning very fast, the pitch or the distance traveled. Pitch is the distance traveled of the vessel in one rotation of the propeller. So that is pitch. So the pitch here is fixed. That's why this is called fixed propeller. So for example, the distance traveled in one rotation is 2 meters. So in one rotation, the ship will run 2 meters because that is fixed. 2 meters. The rotation, so the ship will run 4 meters. So 3 rotation, the ship will run 6 meters. So always times 2, for example, because this is fixed propeller, so the pitch is, or the distance traveled in one rotation of the propeller is fixed. So this is fixed propeller. So next we will go to the controllable pitch propeller or CPP. What is controllable pitch propeller on ships? The controllable pitch propellers can be used to run the ship in forward and astern direction, both without the requirement to change the direction of the rotation of the engine, while the propeller works on the principle of lift generated by its aerofoil section of the blade. By the way, I forgot something here. So this fixed propeller, this is applied to, or this is applied to the direct coupled engine. Why? The direct coupled engine, there is a system in the engine which is reversing. So when the engine is able to reverse, this propeller will reverse, and the movements of the ship will also reverse or will move backward or astern. So this is installed in the direct coupled engine, direct coupled propulsion, engine propulsion. But here, without the requirement to change the direction of the rotation of the engine. So here the rotation of the engine is not required to reverse, because here, as you can see this simple video, this is moving. You can see the blade. So the operator, example the captain of the ship or the master, will maneuver. They can change the pitch. So if he changes the pitch here into no load position or in zero position, your ship is not moving. But if he increase the pitch into load position, for example 15 degrees, 20 degrees, something like that, as you can see here, the ship will moving if he change the pitch. For example, if you are familiar with a helicopter, so when the propeller of the helicopter, if it's still in the ground is, or even on the top, supposedly in the ground, is the propeller of the helicopter is moving in very fast, but the helicopter is not moving upward because the pitch is zero. But if the helicopter propeller pitch is set to, for example, 5 degrees, 10 degrees, 15, 20, and so on, so it will moving up the helicopter. So this is the same. If you put the blade in a zero position pitch, the vessel is not moving, even this is turning very fast. But if you put the pitch into a load position, for example 5 degrees, 10, 15 or 20 or so on, so the blade the ship is moving. So this is the controllable pitch propeller. So you have to control the pitch in order to control the movements of the ship. So as you can see here, the blade or the aerofoil, see, of this propeller blade is moving. So this is controllable pitch propeller. So here we are required to explain the label diagrams that indicate the major components, typical maneuvering and reversing system for propulsion diesel engine. So this is main engine maneuvering system. So this illustration is coming from the simulator, but in the actual is also the same. It depends only the installation, but the system principle is the same. So as you can see here, the maneuvering system, this is already ready for maneuvering. So this is puncture valve. So puncture valve is inside here in the fuel pump or injection pump. This is also indication of the remote. So this means that the control is already transferred to the engine control room. So these are all solenoid valves. As you can see, these are all solenoid valves. All of these you can see are solenoid valves. So it's just indicated here. See, there's green indication. That means this line is open. So we have here also the start air valve block is open indication, safety air valve block open indication, and start air distributor valve block is open indication. So the solenoid is this one. You see, as you can see, there is a line. Solenoid is this one. Solenoid is this one. So this is maneuvering system. Here also have a reversing mechanism. So as you can see here, so this maneuvering system is applied to the direct coupled propulsion diesel engine, direct coupled, because there is a reversing mechanism. So this is a camshaft, you see. So when the cam here is in this side, the lifter pulls this side of the cam. So it might be the forward rotation of the ship, the engine, and in this side of the cam also it might be the reverse rotation of the engine. So this is reversing mechanism to shift the position of the cam to reverse or to rotate the engine in reverse and in counterclockwise rotation or anti-clockwise rotation, or in clockwise rotation or to the right rotation. So this is our maneuvering system. So we have here, so this is a part of a maneuvering system. This is a throttle of your engine, and this is a telegraph, or your engine telegraph or bridge telegraph. So when the one who operate, example, the chief engineer or the captain, the chief engineer in the engine control room and the captain on the bridge, example, who will maneuver this engine. So depends on the command from the bridge. When the command is ahead, so for example, the chief engineer will maneuver, so the chief engineer will start the engine ahead, so the vessel will move forward. When the command is astern, so the chief engineer will start the engine astern. then the vessel will move astern or backward. But they can also, when the captain will maneuver through the bridge, they can also start ahead and stop astern. Start astern and then stop. So this is a part of our maneuvering system, the telegraph and the engine throttle. So we are required here to demonstrate the procedure on how to prepare engine for starting and stopping using the actual institution engine simulator and monitor operation based on the given instruction. So we make use of the engine laboratory ROM or engine simulator ERS for conducting these laboratory exercises. So I will show you the actual simulator to operate to demonstrate this required learning outcome. So in this demonstration, we are using actual engine room simulator. So we are required here to demonstrate the stopping, the starting, the stopping, and reversing. So as you can see here, this is located in the engine control room, this space. So that we don't have alarm with the lever mismatch. So we will maneuver this this simulator to the bridge. So now we will transfer so that the bridge can maneuver this engine throttle to the bridge to maneuver the ship. So as you can see here, this is the control, the responsibility is in engine control room or ACR. So we are going to transfer to the bridge so that they can maneuver to the bridge. So the captain can maneuver to the bridge. So we will press this button to the bridge. So now, as you can see, the button indication is blinking. So meaning, they are not yet acknowledged the transfer of the responsibility to the bridge. Now, we will transfer to the bridge, so the bridge will acknowledge. So now this is in the bridge. So main engine bridge control. The one before was auto chip main engine control. This means this is located in the engine control room. So let us go to the bridge. So this is main engine bridge control. So the bridge, so the captain will acknowledge. So now, as you can see, it is stop blinking. So because the bridge is already acknowledged, so the engine control room also already stop blinking because the bridge already acknowledged. So the responsibility now is on the bridge. So maneuvering responsibility on the bridge. So now we are required to demonstrate the starting, stopping, and reversing. So we will start now. So as you can see here, there is no alarm. So everything is, the parameter is okay. All alarm. Starting air pressure is 30 bar, that is normal. So we have no alarm. So everything is normal. So now we will start slow ahead, this one. So the bridge, the captain will start slow head. So this is how to demonstrate the starting. So when there is a separate telegraph, so we put the telegraph into the slow head for starting. So ahead. But if this is combination of the main engine throttle and the engine telegraph, just like my ship before, so I experienced. So we just move the telegraph into this slow head. So now we will start. So now we will start in this slow head. So this is the slow head. So now as you can see, the engine is running. See? Engine is running. So the captain start the slow head. So if we want to increase the RPM to slow ahead, so we just put there and in slow ahead. So now the RPM increase. In here, in this system, because this is automated system or automation system, there is a load limits program. So load up program. So your engine will not increase, or your vessel will not run fast, because your engine will not the engine will not run fast because the load program. This is for safety reasons, safety purpose. So we have here the load program, load limits eliminated. So we already demonstrate the starting of the main engine while maneuvering. So now we will start the main engine. So I will show you how we will stop the main engine. So now we stop the main engine. So now the engine stop. Engine stop. So as you can see, so we have no alarm here because we did the right maneuvering. So we did the correct maneuvering. So we have no alarm. So as you can see, your starting air going down, but don't worry, your compressor is running. Air compressor. So we already demonstrate the starting, and we already demonstrate the stopping. So your engine is stop. Now we will also demonstrate the reversing, how the engine will reverse and how the ship will move astern or backward. So we will start to astern. So now, if this telegraph is if this system is separate, the main engine throttle and telegraph, you have to put the engine to the telegraph to astern. But if this system is a combination of the engine throttle and the telegraph, the engine telegraph, so we just move this throttle to astern. So for example, this is to astern. So the command is this to astern. So we will start to astern, to reverse. So now your engine is running and your command is astern, as you can see. So this is slow astern. So this is reversing. Your engine now is running in reverse. Running in reverse. Your engine is running in reverse. Your ship is moving backward. So this is reversing. We already demonstrate the starting, stopping, and reversing. So now if we increase to slow ahead, slow astern, so we just increase here. So as you can see here, your RPM is increasing. So your ship is moving backward or astern. So we already demonstrate the starting, stopping, and reversing. So this is already reversing. So your ship now is moving. So as you can see here, your starting air pressure is moving down because we use air to start the engine. So now you see the command is astern. Before it was ahead. So we have no any alarm here because we do the right maneuvering. So we have no alarm. We have no problem. So again, we stop the engine again. So now we stop the engine. Your engine command stop and your RPM is 0. So that is how to maneuver the ship as this required demonstration, the stopping, the starting, stopping, and reversing. So this is the end of discussion. And so we will put first our command to ahead. So we will kick the engine to ahead. So we will kick the engine to ahead so that the command will be transferred to ahead. So now as you can see, the engine is running. See? So now we will stop again. So your engine stop. So we have still fuel here in command. So we'll make it 0. So this is almost 0. This is pointed because this is digital. So your engine RPM is in 0. So now your command is in ahead, your cam is in ahead position. So we already discussed we already demonstrated the starting, the stopping, and the reversing of the engine. So I will stop this. This is the end of the discussion for this week. And please subscribe my channel. Please click share. Please click the notification button. And don't forget to subscribe. See you on my next video. And thank you for watching.